Many different types of radio frequency cables can be used on radio sites, but Ericsson recommend Andrews for feeder cables. Today we are going to be fitting the Andrews Heliax AVA cable with the positive stop connector which Andrews have specifically designed for the cable. The connector comes complete with assembly instructions, two tools that are used for positioning, and the actual connector itself. In addition to this, you'll need some sort of tool, and Ericsson provides a custom tool kit here for fitting the feeder cables. In addition to this, you may want to have a tape measure, although Andrews have thoughtfully provided a measuring scale on the instruction sheet itself. To begin fitting the connector, we will put the end of the cable 50mm from the end, and we just cut the outer insulation. The next thing we need is this saw guide, and the saw guide is fitted over the end of the cable so that it guides the saw, and this way we can cut a perfect vertical edge on the end of the cable. However, when you cut using an ordinary saw, there's a lot of sawing debris, and if you was to just cut this now, the debris will go down the inside of the cable all the way down to the other end. This is not allowed. So, the cable should be angled downwards, and that way any sawing debris will fall out of the cable instead of going into it. The piece should be positioned at around about 38mm from the insulation. 38mm, perfect. So now we just cut the cable using the guide to guide the saw. So the end of the cable is now perfectly vertical. Next we must deburr it. We want to start off by preventing the inner from damaging the inner conductor of the connector, and we start off by deburring the inner. Just cut off any possible burr. The next step is to deburr the copper outer, but on the inside. The next step is to trim the outer of the outer conductor. We do this using a file. And finally, there may be possible pieces of debris or copper on the end of the dielectric. This has got to be removed. We do this with a metal brush, brushing from the centre outwards. We brush from the centre outwards to prevent any debris from being brushed back into the cable. The next stage is to use this tool to open up between the outer sheath and the dielectric. This gives us a nice gap here, a machined edge. After this, we fit connector components. Fit the clamping nut over the end of the cable, and then fit the spring washer into the first groove. The connector body is next inserted over the whole assembly, and the clamping nut is screwed in and tightened. Notice how the connector body is not being moved, it's only this clamp at the rear that is being rotated. What we have to do is to tighten it up so that that gap there is closed. And only when that gap there is closed is this seal tight and we have a proper electrical connection. Grip this one. Do not use a poly grip, by the way. You must use a parallel clamp or an ordinary wrench. Now, as you see, that gap is totally closed. The connector is secure, it is sound. So you tighten only until that gap disappears. But notice, you do not need to use a torque wrench for the positive stop connector. Notice also that there's a plastic cap over the connector itself. Leave that in position until you actually require to connect the feeder cable to the jumper. That's it. The Andrews connector fitted to Andrews cable. This is the Andrews EasyAxe cable preparation tool, which is made of toughened ABS plastic. We're going to use it today to prepare some AVA cable to receive the positive stop connectors. The Andrews instruction sheet contains a lookup table to tell you which blade hole to use for the cable type you are using. The cable is cut by the blades in the tool. There are 2 blades, and these are okay for about 20 different cable preparations, after which you should change the blades. You can easily change the blades by removing the top here, and there are the blades contained in compartments inside the lid. This blade cuts the centre conductor of the cable, and this is the blade that should be changed every 20th cut. This blade here cuts the cable outer jacket, but that will actually last up to about 100 cable cuts. The blades are inserted into these slots, and as you can see here, the slots are marked depending upon which cable is going to be cut. When you're changing the blades, be very careful, because if you have to press, be careful you don't push your fingers onto the blades themselves, they're quite sharp. So now we're going to prepare the cable. To prepare the cable end, we need to start off by manually removing a little insulation, around about 38mm. So we measure that, and then we score the insulation on the cable. And peel off the insulation. A couple of small points about safety here. The knife itself, of course, personal safety is important, but if you cut too deeply, you could actually damage the surface of the copper. That would damage the cable, and you would have to remake the joint. There is also one other consideration, and that is you yourself. Before you do any work, you should be physically clean. That is to say, copper can be tarnished by, say, the grease from foods, or it can be corroded by the acids from fruit. So if you're going to have lunch before you do this sort of a job, wash your hands properly first. The tool is equipped here with markings and arrows to show you which way it is to be rotated. We want these arrows to point towards us because we're going to turn it anti-clockwise, and it will be turned around about 8 turns. Be sure that this blade is over the cable. So applying a firm but even pressure we rotate the tool. Don't press it too hard. After about 8 revolutions, the tool will appear to go free, and when we open it, we find that the end has been cut off and the cable is prepared, almost ready to receive the connector. All we have to do is to just cut off the last little piece of insulation. And now the cable is prepared, ready to receive the Andrews positive stop connector. Andrew also supply a cable preparation tool that fits into an ordinary electric drill. Again, the tool will accept cables of different sizes, and to do so, there is a chart in the cable in preparation tools instruction sheet, and blades can be inserted into different places here. This is the RPC position, but we're going to use the standard position, and so the blade is inserted in here. By the way, these blades can each be used for about 150 to 200 cable preparations. The tool itself just simply fits into the hand-operated electric drill, the high torque, and then we fit this over the cable, and everything is done automatically for us. It cuts off the outer insulation, it also trims the end of the cable, and ball bearings drop into the slots of the cable, so the end of the cable is perfectly positioned. Okay. And so now we have another perfectly prepared joint ready to take the Andrews connector.